Yeah. So we have a separate planning node with a more powerful LLM that breaks down the initial task, right? It thinks through and decomposes the task into several steps. So typically in this pattern, as we have multiple subagents, so the planner is decomposing the original task into multiple subtasks, and then it delegates each task to a specific specialized subagent, which typically uses the React architecture that we discussed. So each subagent again has got a number of tools at its disposal. It has got its own system prompt, a specialized system prompt, and it is meant to basically perform a specialized task. So each individual subagent then execute the task assigned to them by the planner agent, and they basically input back the results back to the planner. So planner, once the planner gets uh, the feedback or the results from each of the individual subagents, then it sees whether the initial task or the initial objective is completed. It can complete the task using those results. Then it gives back the response to the user. If it sees that the task is still not complete, then it does further planning and makes further calls to subagents. So all this execution happens like within this loop. So each subagent in this design is a React agent, and on top of like multiple React agents, you have this planner node or the planner agent. So this is your hierarchical agent architecture, or you can call it the planning pattern or multi-agent architecture. So this is what the tech stack for building agents looks like. At the base, you have the infrastructure like your vector databases where you store information. You have got your cloud infrastructure where you do the deployment, etc. Then you have the tool layer. So in the tool layer, model context protocol is very important. Basically, this is complete topic in itself. So we will not discuss this in detail, but basically it's a way of exposing APIs, functionality that APIs expose. So it is a way of wrapping the API functionality that is easily interoperable with the LLM infrastructure. So it provides a standard protocol of invoking tools and getting responses back from the tools. So tools consist of these MCP servers, APIs, databases, file systems, etc., web browsers. So additional capabilities that you can use to extend your LLM functionality. Then on top of these tools, we have got different agent frameworks like LangGraph, Google Agent, Agent Development Kit, Creo AI, LangChain, uh, Cloud SDK, OpenAI Agent SDK that you use to uh, build the agents. So these use like different mechanisms. So for example, LangGraph uses graph based agent structure, and other frameworks might use other different techniques, right? So you can choose an agent framework of your liking. to build these agents. On top of the agent frameworks is the LLM. Again, like you can choose a specific LLM, and uh, when we say that LLM, we are actually making calls to the LLM using the exposed APIs. So you can use GPT-5, Claude, Gemini, whatever suits you. And in these also, like you have got different model sizes. So depending on your use case, you can use multiple LLMs in a single agent as well. For example, in a planning node, you can use a bigger LLM, and for the React loop, you can, if it is a simple React loop, you can choose a smaller LLM to reduce your cost. And the topmost thing is the task or the goal or the objective that you define for the agent, that the agent needs to achieve. So these are uh, the stacks of modern agent architecture: user goal, LLMs, agent frameworks, tooling layer, and the infrastructure. So we are coming to an end of this presentation. So agents are the future, because through intelligent agent design, you can solve a lot of complex problems and automate a lot of things which was not previously possible. So that is the next big thing in the world of AI, like intelligent agents. And what you can achieve with intelligent agents is limited by your imagination only. It's a very interesting field to be in, and a lot of developments are going on. It's moving very rapidly. A lot of new stuff is coming up, like agentic memory, context engineering, prompt engineering. So you need to like keep up with the latest in the field to be able to like design good agents. So this brings us to the end of this conceptual introduction to agentic AI, and this will help us when we actually do a deep dive into the email agent system architecture, right? Which we are going to do next. Yeah, thanks.